Hi, I'm Ben Farr.
I'm Eric Lenhart.
And today we're going to discuss Phillips IntelliView patient monitoring systems. Our main focus is going to be the MMS system, which monitors the patient vitals. So in this video, we're going to focus on different types of modules, and then we're going to move into how to test the actual modules, and then finally we're going to move into repairs. The focus is on the M3001A model, which is very important because it takes the patient's vitals. There's controller boards and also pumps on these. These modules that are hooked up to the monitoring system also report back to the central monitoring system in the hospital so that the nurses can monitor us from the central station.
Okay, we're talking about the Phillips monitoring system and some of the equipment that you might find in the system. In a typical hospital, you'll have some transport monitors that can be carried around as they transport the patient from one department to another. And then you'll have monitors mounted by the bedside that are more permanent. Under the bedside monitor, you'll typically have the FMS rack, which allows for interchanging different modules to measure different things on a patient. On the end of that, you can have the main module, which they call the multi-measurement server, the MMS module. Here's an older one that we put a gray cover on it so that we know that it's the old one. It only works with certain old monitors and not the newer updated software. Then you have extension modules, which can add more ports and more connectors to get more measurements into the system, or do a different type of measurement, such as the microstream. This does the end-tidal CO2 measurement typically for patients that are on a ventilator or have breathing difficulties. And the module that you'll find the most is the M3001A, and that's got multiple ports in it. So you can measure the ECG, the SpO2, the NIBP, and arterial pressure, and temperature. So some of the test equipment we have for testing the monitor and the module, because you have to hook everything to the module to test the monitor. You have to be able to carry this around the hospital to do your PMs and test all of your equipment in the patient room typically. So you take your patient simulator and a set of patient leads, the 5 lead connectors and a cable to go to the module. Then you have a patient simulator for the SpO2 for the finger. You'll have a arterial pressure simulator, which is basically a different set of resistance, and you can cycle through the resistance and see it on the scale on the arterial pressure output. You have a test setup for the temperature input. You can use a resistor setup and get the resistance to indicate a temperature that is in the correct range. So it'll either alarm, you could make it alarm or not alarm if you want to with the right resistance setup. Then you have a blood pressure setup. You have a blood pressure cuff and cable, the hose. You have to wrap the blood pressure cuff around something so you can do it without wearing your arm out all day long. You can also have a blood pressure simulator that will give you an output and read it on the screen. So when testing the ECG on the monitor, you use your patient simulator. If you have the patient simulator turned off, you have no heart rate. You should get an asystole alarm. Then you turn your patient simulator on. We'll start at start at 30. Just get the low alarm here. go to a normal heart rate of 60 beats per minute. The alarm should go away. Now from a normal heart rate of 60, you should have no alarms going right now. A nice steady heart rate shown on the screen. You can go into your patient simulator, change to a high heart rate, go to 300. So we'll see it raise up to 300. You should get a bradycardia or extreme cardia alarm. When you're in a patient room, you want to get rid of the alarm as soon as you can, or the nurses will come running. Okay, so when you're testing the SpO2, it's good to have a patient simulator. This is the OxSim by Pronk Technologies. It's a simulator of a patient's finger, and you can go through different modes. The normal mode would be a 99% SpO2 with a pulse rate of 80 beats per minute. And you can hear the beats per minute beeping. So then when you go through your simulator, you can go through different settings on it. Right now we're at 98% and 140 beats per minute. So you'll see that the pulse rate will change to 140. You're getting a alarm for the high pulse. Go to your next setting, which is now 99% SpO2 with low perfusion. That's the pulse high for the 140 beats per minute. Should go away. The perfusion is down to 0.23 right now. Go to our next setting. 85% SpO2 and 80 beats per minute. You should see this change. Sometimes it takes a few cycles across the screen for it to change the reading. So now our SpO2 is dropping. So now we get a low SpO2 alarm. And you would want to pause this so the nurse doesn't come running. We go to 95% SpO2, 40 beats per minute. Just get an alarm for low pulse. Pulse low. We'll return back to 98% SpO2 and 80 beats per minute. Should all return back to normal. Okay, to test the blood pressure pump, you need to have a setup with a blood pressure cuff. Then you can use a patient simulator for the blood pressure that will give a electronic pulse, basically. So then you start the blood pressure pump either from the monitor or from the module. You'll pump up your blood pressure cuff. The patient simulator senses that you're getting pressure. It'll tell you you went up to around 156 millimeters of mercury. Then it starts the electronic noise, which is simulating the splashing sound of the blood. And the pressure drops off. And then you'll come up with a reading. We got 114/78 with a heart rate of 86. And this should be a fairly repeatable set of numbers by the patient simulator. If you can't get it repeatable, then you may want to check out, make sure your pump or something is not leaking. Alright, to test the arterial pressure output on the screen and through the module, through the pressure input on the module, we have another patient simulator, and it is basically a set of resistors and different settings on the resistor. So you'll start at 0. You can 0 your arterial pressure. And you cycle through. You should get a change in the reading. Go to 20 millimeters of mercury. And you'll see this raise up on the scale each time you change this, and a number to match. Sometimes it takes a little bit to settle in, and you go up. Another setting will go up to 100 millimeters of mercury. This would come from an arterial line with an arterial pressure sensor. It'll come up to 100 millimeters of mercury. The higher you go on the scale, the longer it takes usually for it to settle down. You can go all the way up to 300. You'll see it jumps to the top. The number will rise quickly at first, but then it takes a little while to get all the way to the top. Okay, so for testing the temperature input, which is the little brown connector, shows up on the screen right now. We have a question mark that shows that there's no input. So we can use a probe that will test the air temperature to give us a low temperature alarm. 24.4 degrees Celsius. Should be out of the normal range and give us a temp low alarm. Should reset. With our resistor setup, we should have it in range, a resistance that will give us a temperature that's in range in the 36 to 39 degrees Celsius range. 37.7 degrees Celsius. We don't get any alarm. And a simple 1K resistor will give us a high temperature alarm. Now we have an input question mark because it's still trying to read it. We have a 39.6, it's above the 39 limit. We should get a high alarm. Temp high. Okay, so the MMS module is a piece that can be disconnected from the monitor and used during transport, or to change the inputs that you want and add the extensions. In that, the extensions can be dropped, everything can be dropped and broken, so you have to actually pry this connector apart to change the cable. It feels like you're going to break it when you're tearing it apart. Some of the other things that can go bad in here are some of the ribbon cables, or the connectors can be actually broken. The front bezel can be broken. The blood pressure pump will go bad after a while. You'll see black powder in here from the brushes of the motor wearing out, and it will not start all the time. As they drop them, they'll break parts off, and you may have to change the frame or do some soldering, repairing things, and we'll get into some of the repairs on the module here. Alright, here we have a module that has been dropped in the emergency room. They tend to beat things up, they get in a hurry. So to repair it, we know that we already have some broken pieces in there rattling around. You have to actually pry off the front bezel, and it feels like you're going to break it. You pry it off. There's white pins that hold it together. They're called chopsticks because they resemble chopsticks. Take the top cover off. You find some of your broken pieces. We have a resistor that has broken off and some plastic pieces. This holds the white pin in place here, and if not all these are in there, it won't hold the cover on correctly. Now the cover keeps the pressure on the power board. It's a DC to DC power board. Then as they bounce it around, it can come disconnected. So the white pins have to hold the cover on to hold the power board on. So the resistor that I found here came off of the power board. So at a close inspection, you'll know that the power board is probably bad. Sometimes you can solder things back on and make it work, but typically you have to order a $400 power board. The blood pressure pump can wear out over time. Gently pull it off. It will have some black soot from the brushes wearing and everything in the motor going bad, and over time that will cause bad connections and you'll have to replace it with a new one. Those are great, like $400 or $500 a piece. When they drop them, when they drop the modules, it will shift things inside, and this is the blood pressure button here, and the pins that connect this button board to the main board have sheared off, and it just has to be soldered back on. So you'll have to gently get in there, solder each of the 6 pins on. Then you'll plug it back into the monitor and test the button, make sure that it works. Some other things that can go wrong is the MSL cable. Again, it takes some prying to get it apart. Some of these will actually break the connector right in the middle. Some of them will break the ribbon cable, and you have to replace that. That's about $90. Then you have the main board, and this is kind of protected by everything else around it, but there are some things that go wrong with it. There's another ribbon cable which over time can break in the fold area. The connectors are made so that you can't plug in the same cable in any one of the other connectors, but people try, and you can see that they've been rounded, and they can tend to get loose over time and break the connections on the back of them. When we open the bottom, there's more white pins to hold it in place. And you'll see that you have a separate board for your arterial pressure is on this board. Your SpO2 is on this board, and your ECG is on this board. So you may have spills inside here that could short things out. It can make one board go bad when the rest of them are still working. That's why you need to do a thorough test when you do a PM on these.